Afternoon. Today's lecture topic is going to be integers and order of operations. As always, I am taking this, the shell of what we're doing is coming from the lecture notes I posted on Blackboard. So if you go to the study resource for Unit 1, our integers 5.2, integers order of operations. I'm going to do order of operations on a later video. This one is just going to be the integer part of the negative numbers. All right. A quick comment just about negative numbers in general is even more so than fractions. Integers are probably the most common source of mistake in a math class. I don't care if it's like an intro math class, if it's this sort of math class. In my calculus class, I taught that the most common mistakes were usually with dealing with negative numbers. I think a large part of that has to deal with, again, how it's taught. If I ask you what are two negatives, generally that response I'm going to get is it's a positive. And my response is, well, is that add, subtract, multiply, divide, what? Well, and it turns out that the rules that we remember for negative numbers is almost always for multiplying and divide. And something we saw with fractions is when you add, subtract, it has different rules than multiply and divide. And so same happens with integers. Now they are related, which makes it a little bit more confusing. But you just have to remember that when you're actually subtracting, you got to be a little bit more careful, slow down, because you're probably more likely to make mistakes with adding, subtracting with negative numbers. Also, parentheses matter, right? And that's something that we'll talk about when we get to exponents. All right, so quick comment about opposite of and absolute value. We don't use absolute value a lot in this course, but it does pop up occasionally. So opposite of, yes, that just does mean change the sign. So opposite of a negative number is positive number and vice versa. If we're wanting to write that in math symbols, all we do is put a negative in front of the number. So anytime you have a negative number out in front of a grouping symbol, which is usually parentheses, that just means you're changing the sign. That we have no problem with. We're used to using that. Absolute value tends to cause more problems because we don't use it near as often. And so often students treat absolute value just like opposite of, because half the time it acts like opposite of, but it is different. And so the definition of absolute value is it's the distance of a number from zero. And so distance is always a positive number. So the answer to an absolute value operation is going to be positive, unless we get a negative on the outside, and then that gets more involved. But absolute value makes a number positive. If it starts positive, it stays positive. If it starts negative, it goes positive. And the symbol for absolute value is those two little vertical bars. So that is what our absolute value looks like. All right, so let's do a couple quick examples of this. All right, so I'm going to skip the opposite of, we're good with that. So absolute value of negative 21. Well, how far is negative 21 from 0? It is positive 21. Now, you don't have to put positive in the answer, like when you're doing math lab, but the notes, since we are specifically talking about positive and negatives in this lecture, I'm going to put those little positive signs up there just for emphasis. Okay. So what is the absolute value of 7? Well, if you're thinking negative 7, you're reverting back to opposite of. But how far is 7 from 0? It's 7 steps. The absolute value of 7 is 7. What's the absolute value of 0? Well, 0 is 0 steps from 0, so it is 0. Okay, now where it gets a little messier is look at 7 and 8. So on 7, we have, how do you read that? Well, that is the opposite of the absolute value of negative 12. And we haven't officially talked about order of operations, but if you look at that and think, well, two negatives make a positive, you're basically just multiplying those. You're treating that like number 7, which has parentheses instead of absolute value. But anytime you have absolute value, it is an operation that has to get done first. So that's the higher priority. So what you're actually doing number 7 is that negative gets carried over for now. And then what is the absolute value of negative 12? Absolute value of negative 12 is a positive 12. And then what's the opposite of a positive 12? It is negative 12. So even though we had absolute value in the problem, doesn't mean the answer is positive because that negative on the outside makes the positive number a negative. But it comes back to order of operations. We do inside the absolute value before we do the opposite of. So opposite of is basically is multiplying by -1 essentially. And so we got to do our grouping symbols before we do our multiplication. Now on number 8, the opposite of -11, there is nothing to do with those parentheses. That's just to separate the signs. So the opposite of a negative number is a positive number. That would be positive 11. And then the last one, well, we got 2 more. So the opposite of number 9 is the opposite of the absolute value of positive 33. Again, we're going to bring that negative down for now. So what is the absolute value of positive 33? Well, absolute value makes it positive, so it stays positive 33. Opposite of a negative is now negative 33. So like I said, these two in particular, 7, 8, and 9 get confused all the time because we're so used to saying opposite of all the time. Since we don't use absolute values much, we tend to just treat it like parentheses and we get off track a little bit. Now, what about number 10? Absolute value of 8 minus 10. Well, this kind of gets into order of operations, but again, do we just make everything in there positive and say 8 plus 10? Well, the answer is no, because of order of operations. So what order of operations is we have to do inside that the absolute value first. And we haven't officially talked about the adding subtracting yet, but 8 minus 10 is -2. And so the absolute value of -2 is a positive 2. All right. So for this course, the only thing we're going to do with absolute value for the most part is a few order of operations problems. We'll throw that in there. So I just wanted to kind of show you that just as a refresher. All right. So let's get back into our negatives here. So for multiplying and dividing, these are the rules that most people remember. And so let's just do a quick summary. So if you have a positive times a positive or positive divided by positive, the answer is positive. If you're doing one of each, either positive, negative, or negative, positive, when you're multiplying or dividing, the answer is negative. And if you're multiplying 2 negatives or dividing 2 negatives, the answer is positive. And so if I was to summarize that in a sentence form, so when you're multiplying or dividing, if the signs are the same, then your answer is positive. If the signs are different, your answers are negative. But that's for multiplying and dividing only. For add and subtract, we have to talk about something different. All right. So I'm going to go through. I'm not going to go through all of these. I do want to point out something like on number 15. How do you know, like ahead of time, if that answer is going to be positive or negative? There is a shortcut when you're multiplying several numbers at once. That goes by the number of negatives. So here we have 3 negatives, which is an odd number of negatives. That tells us the answer is going to be negative. And the reason being is like the first 2 will pair up to be a positive, and then you have 1 negative left, so your answer is going to be negative. And then 2 times 2 is 4, times 2 is 8. So our answer is -8. Now, how would you multiply 16? So some of you are probably just going to start on the left and work your way to the right. If I'm multiplying 4 or more numbers, I'm going to multiply them in pairs to kind of save some time. Because if you're just multiplying, it doesn't matter what order you multiply in. So I would do -4, or 4 times -1, which gives us -4. 8 times -5, which is -40. And then negative times negative is positive. So we get positive 16. And I knew ahead of time that answer was going to be positive because we had two negatives. We had an even number of negatives. And so when you have an even number of negatives, they will pair up and give you a positive. And there's not a negative left over. So that's sort of the shortcut there. When in doubt, you can always just multiply them. Okay. So for example, number 17, -6 times -1 times -5 times -2. That answer positive or negative? Well, you have 1, 2, 3, 4 negatives. So negative times negative is positive, negative times negative is positive. It tells you your answer is positive. Okay. And then, that's 6 times 1 is 6. That gives you 10. So your answer is 10 times 6 or 60. Okay. Now, one of my fun questions is number 18. So what is that answer? Well, -26 times 10 times -4 times 0. I used to have even more numbers in here. If you're multiplying those to get the answer, you're doing it the hard way. So don't forget, anytime you're multiplying with 0 as one of the numbers, that answer is 0. It doesn't matter what the rest of the problem is. Okay. So like I said, multiplying by itself, pretty straightforward. Those are rules to remember. So I think we're good there. Now here's where the multiplying causes problems, and we get into exponents. Because I don't think we teach you well enough the importance of the base and how that connects with parentheses. So when you have -9 with parentheses squared versus -9 squared without parentheses, are those the same? Are those different? Well, if you're thinking they're the same, then that's why we're doing this, because parentheses absolutely matter when we're dealing with exponents. So on the top one, since that negative's inside the parentheses, well, anything squared means something times itself. So that is -9 times -9. Then we have negative times negative, so that's positive. On the second one, without the parentheses, right? So this is, what's the base? What is getting squared? If there is no parentheses, it's just what's immediately to the left of the exponent. So the only thing getting squared in the second one is the 9. So if you're writing it out, there is one negative, and then you have 9 times 9. This is essentially the opposite of 9 squared. Right? So that's going to give us -80. This is one of the most common mistakes with negative signs. Like I said, I've even had calculus students still make this mistake. Okay, so you just got to slow down when you're dealing with exponents and negatives. The way I remember it is when you're dealing with negatives and exponents in parentheses, if the negative is inside the parentheses, if you write it out, you have as many negatives as the exponent. So that's why we have two negatives, because that's the inside. If you don't have a parentheses, you only have one negative. All right, so let's look at the next couple problems. So if you have -2 cubed without parentheses, you write it out, how many negative signs do you have? Well, there is no parentheses, so you have only one negative sign, and you have 3 2's. So what do you have? Well, -2 times 2 is -4. -4 times +2 gives you -8. Okay, so what about the next one? So -4 cubed with parentheses. So if you write it out, since it's in parentheses, now we're going to have 3 negatives. So what is that answer going to be? Well, since I'm multiplying an odd number of negatives, this is going to be a negative answer. And then 4 times 4 is 16, times 4 is 64. So the answer is -64. All right, so this example is part of the reason why this causes a lot of problems. Is if you look at this, you might look at that and say, well, it doesn't matter on the parentheses because I got a negative answer either way. Okay, but the reason we got a negative is different. So in 21, we got a negative because we were multiplying one negative. On 22, we got a negative, so we're multiplying three negatives. Okay. So, I mean, you only have, when you're multiplying, it's either positive or negative. So, but since we're getting there by different reasons, the parentheses are still important. Okay. So you could think like half the time you can ignore the parentheses and be okay if you have odd exponents. But if you have even exponents and you're not paying attention to parentheses, like half the time you're going to get a wrong answer. Okay. But just be careful with your parentheses and your exponents and your negative signs. Like for example, number 23, how many negative signs are you going to have there with -5 to the fourth power? Well, since there is no no parentheses, there's only one negative, right? So our answer is going to be negative. And 5 times 5 is 25. 5 times 5 is 25. And 25 power, so 25 times 25, sorry, is 625. And it's going to be negative because of the one negative. Now here's something that I do want to point out since I grabbed a calculator. Okay, so notice that, and when you're doing negatives, make sure to use these calculators are different. For this calculator, it's a negative in parentheses. If you use a subtract sign or subtract button, it's going to actually try to subtract like your previous thing. So make sure you're using negatives. So notice that, and if you want to do a power other than 2, the up arrow, a lot of calculators have it like an X to the Y button. So I do that. That gives me -625. And then if you want to do it in parentheses, you get a positive 625. Okay. Now here's the thing. Just because you put it in the calculator does not guarantee you're going to get a right answer, because the calculator doesn't know what's originally written on the paper. The calculator only knows what you plug into it. That's what it's going to find the answer for. And very often, if you're a little fuzzy on some of these topics, you're going to interpret the problem and you're going to type in the calculator your interpretation of it, not necessarily what's written on the paper, if that makes sense. So if you're using your calculator as a backup, try to be very careful about typing it in exactly like it's written on the paper or in the math lab or wherever. Because once you start interpreting it, then you can be putting, entering stuff in your calculator incorrectly. Right. Now here's a fun one. I like this one. -1 to the 24th power. Okay. So first of all, is that going to be positive or negative? Well, if you write it out, that negative's inside the parentheses. So you're going to have 24 negatives. Since you have 24 negatives, that's an even number of negatives. Our answer is going to be positive. So what is 1 to the 24th power? If you think 24, you've fallen into like the common mistake that are made with exponents, that your brain sees the 1 to 24, so it's really quick to multiply it. This often happens with 2 and 3. 2 to the third power is 8, but very often you hear 6 because people look at that and say 2 times 3. This is just, once you take the negatives out, this is just 1 times 1 times 1, which is always going to be 1. All right. So this works the same with decimals and fractions. So if you look at 25, how many negatives do we have? Well, there is no parentheses, so there's only 1. 0.8 is what's being squared. And I don't know about you, but normally when I'm dealing with decimals, often I just grab the calculator. That's going to be -0.64. All right. What about 26? How does fractions impact all this? Well, same way. That negative is inside the parentheses. So that means if we were to write it out, we'd have -2/3 4 times. Okay. Well, how do we multiply that? Well, again, you're multiplying top with top, bottom with the bottom. You can see there's nothing to simplify because, 3 doesn't go into 2. This answer, we've got 1, 2, 3, 4 negatives, so our answer is positive. So what's our answer? Well, what's, 2 times itself 4 times? That's 4 times 4, which is 16. And that's 9 times 9, so 16 firsts. And again, it doesn't hurt to make sure you can do something like this on your calculator as a backup. So make sure to do parentheses, because again, there's parentheses in the problem. And then negative, get over d, so we're going to 2/3. Okay, now notice that the cursor is down in the denominator. Make sure to cursor over. So that way, when you close the parentheses, it's a big parentheses. If I didn't do that, let me show you what that looks like. So if you didn't cursor over, then your parentheses is like just in the bottom, and that's going to cause you an error. And then you want to do the up arrow, or it's called a caret or a hat, up to the 4th. And then there you go. There's your 1680 firsts. Okay, so the majority of the mistakes with multiplying negative numbers comes when we're dealing with exponents. Right, and I can't emphasize enough there the importance of those parentheses. All right, so when it comes to division, division follows the same exact rules as multiplication. So usually I don't need to explain a lot about division. The one thing we do need to talk about is fractions. So let's start with 28. So I have here negative 4 over 7. Does that equal 4 over negative 7? And does that equal negative out front 4/7? Well, let's start with the first two. So the numbers are all the same. So we're just dealing with positive negativeness here. And so if you have a negative divided by a positive, what's the result? Well, that's a negative number overall. If you have a positive divided by a negative, overall, signs are different, so that's negative. And if you look at that negative 4/7, that negative's out front, so that's telling you you have a negative number. The number happens to be a fraction, but it's still just a negative number. That's, if we were to graph that on the number line, that would be somewhere to the left of 0. So overall, that is negative. Okay. So if you're dealing with fractions and you have one negative sign, it in the long run, it does not matter if it's on top, if it's on bottom, or if it's out front. All 3 of those mean that overall you have a negative number. And in math lab, in mathematicians, we prefer to have the negative out front. But if this was a problem, you're working in math lab and you come up with negative 4 over positive 7, that's what you put, it will accept it. All right, so let's explain this a little bit more. So let's look up at 27. So is negative 3/5 equal to negative 3 over negative 5? So we already explained that this negative out front just means we have a negative number overall that just happens to be a fraction. So overall, that's negative. But what is negative divided by negative? Well, negative divided by negative is positive. So these are definitely not the same. So that's probably the biggest mistake with negatives and fractions. If you have a negative fraction, it does not mean both the numerator and denominator are negative. It means one of them is. So watch out for that. All right, so like for example, 31, 24 divided by negative 4. Well, that's a positive divided by negative, so that's negative. 24 divided by 4 is 6. Well, there you go. All right, so let me put 34 on the same page here. Okay. So the only other thing I want to talk about with division, not necessarily so much a negative issue, just it's a good place to talk about 0. So you have negative 73 divided by 0, and you have 0 divided by 53. What are those answers? I'll give you a moment to think about that. And here's a hint, one of them is 0, one of them is undefined. Well, if you can't remember, one of the nice things about that is we are allowed to use calculator. So let's do -73 divided by 0. So you get an error. In this case, it says a divide by 0 error. And so you cannot divide by 0. We're going to say that's undefined. Um, Basically, dividing by zeros, if you're dividing something by 2, that means you're trying to break it up into 2 groups or groups of size 2. But if you're dividing by 0, you're trying to break something up into groups of size 0, and like that isn't even might make physical sense. So you cannot divide by 0. Now, what is 0 divided by a number? Oh, figure that out. So 0 divided by 3 is 0. So if you do 0 divided by a number, it is 0. If you have $0 and you're trying to split it up between 53 people, like how much money does each of those people get? They get nothing. Okay. So this is one of the things, if you remember it, great. If not, go back to your calculator just to be sure. All right. Just one of those little things that pops up here and there. All right. So where the majority of the mistakes are made, other than with the exponents, with negatives, is with adding, subtracting. Okay, and so again, I think the reason why there's so many mistakes made with this is we just don't teach students to stress the difference between multiplying, dividing, and adding, subtracting, because the rules are definitely different. Again, they're related, but they are different. So think of it this way: in multiply or divide, when you want to know if the answer is positive or negative, basically ask yourself, are the signs the same or if they're different? And you don't have to worry about anything else because you know you're multiplying and you know you're dividing. When you're adding, subtracting with integers, you have to know 2 things. 1, are we actually adding? Are we subtracting? And 2, what's the sign of the answer? So let's start. Let's see. Where do I start? But both of these, I would say, when in doubt, go back to the number line, which I know sometimes students think, well, I'm in college. Why am I talking about the number line? Number line works really well to explain, I think, how adding, subtracting works with negatives. Okay, so let's jump down to some numbers and explain what's going on. So if you look at 36, we have -22 plus 11. So I'm going to ask, is that an add problem or a subtract problem? Are we adding those 2 numbers and getting 33? Or are we subtracting them and getting 11? Well, if you look at that and say we're adding because of the plus, what you're doing is looking at just the second sign. But what we need to do is look at both signs. And that's really what's going to tell us if it's an add or subtract problem. Okay, and so if the signs are the same, if they're both positive or both negative, then we're going to add. So signs are the same, you add. Signs are different, you're going to subtract. And the reason being, go back to the number. So if you think of this on the number line, the -22 plus 11. All right, so the -22 says we're going to go left 22. And then we're going to add 11. And when you're adding, you're going to the right. We're going to go right 11. So when your signs are different like this, you're going in opposite directions on the number line. And when you're going in opposite directions on the number line, the numbers are like fighting against each other. Not necessarily a mathematical term there, but that's why you're subtracting. Okay. So anytime you're subtracting, always do the big number minus the small number. You have to be able to borrow if needed. So we're gonna get 11. But now the question is that positive 11 or negative 11? Well, you can see here on the number line that we are in the negative region, and the reason we're in the negative region is because we went left more than we went right. So when you're adding, subtracting, the sign of the bigger number controls the sign of the answer. So sign of the answer is determined by the bigger number sign. All right, so our answer for this one is negative 11. So we're subtracting because the signs are different. Our answer is negative because the bigger number, the 22, is negative. All right. Let's see here. So what about 37? We have negative 11 plus parentheses negative 10. So what do we do with that plus parentheses negative 10? It sort of depends on what you're comfortable with. Some people prefer it that way. What I do is, anytime, this is what I refer to as a double sign, when we have those signs right next to each other, I like to condense it down to a single sign. So we have negative 11. So when we're adding a negative 10, is that really plus 10 or minus 10? Well, there's a couple of ways you can think of it. So if you have double sign like that, you can actually, with parentheses, not an absolute value, you can actually use your multiplication rules. So positive times a negative is a negative. If you think in terms of money, if you're adding negative $10 to your account balance is going down. So that's a subtract, so that's a minus 10. If you think in terms of opposite of, if you have a plus out there, if that was a negative, it means you change the sign, but since it's positive, it means you keep the sign. So we're going to keep that negative. So there's like 3 different ways that's actually going to be a minus 10. All right. So that's what I do first, is I condense those double signs down to a single sign. That doesn't help everybody. Some people, like I said, are comfortable with the original problem, and that's great. But now my question is, are we adding, subtracting? Well, they're both negative. So if you go back to the number line, that means we're going to go left 11, and we're going to go left 10. So both times we're going to the left. And so since we're going in the same direction, then you add. So if they're both negative or both positive, you're adding. Okay, so that's going to give us 21. And is it positive or negative? Well, they're both negative, but the bigger number is definitely negative. We're on the negative side of 0. So our answer is negative 21. So a lot of times with add subtracting, you just need to slow down and remember the rules are different. When in doubt, I recommend thinking of the number line. Okay. All right, we've officially talked about fractions now. So what do we do with that 4/5 plus a negative 3/5? Well, just like the last problem, I would say that plus a negative means 4/5 minus 3/5. And now we have the same denominator. So keep the 5, we do 4 minus 3, 1/5, that's simplified. So we're done. All right, what about 15 and that double negative? Well, again, I would try to condense this. And there's a couple ways to think about it. The negative times a negative is a positive 12. Or the opposite of a negative is a positive. If you think in terms of money, like let's say the bank charged you a $12 fee and they took that fee away, then your bank account would be going up. Now, once you do that, you have 15 plus 12, that's a normal. All right, but I think part of the reason why there's so many mistakes made with abstracting is in real life, like, I don't know, 95% of the time at least, that first number is always going to be positive. And so we get used to not even looking at that. We just look at this to see, because if it's both positive, we add, that's negative, we're going to subtract because you have one of each. But that first number is not always going to be positive. So you really need to take into account the signs of both numbers. That's going to tell you if you add or subtract. All right. So what about when you're extracting multiple terms? Right. So just like with 30, all the rest of these, if I have double signs, I would condense those first. So I would say this is 7 minus 9 minus 3 plus 9. Okay. And then my next question is, what order do you do these in? Well, if you look at that and say, well, you're going to do 3 plus 9 first because PEMDAS says adding is before subtracting. Well, that's one reason why I don't like PEMDAS, and we'll talk about that in the next video. Uh, but when you're extracting, it's not always add first. And if you do that, if you're going to say 3 plus 9, you're ignoring that negative in front of it. So my recommendation, anytime you're adding, subtracting multiple numbers, work left to right. You're much less likely to make mistakes with your negative signs. So it's going to be a little bit longer, so I'm going to get paper. So we're doing 7 minus 9 is 3 plus 9. So here's how I would do this. So 7 minus 9 is what? Well, one's positive, one negative, so we're subtracting. So 9 minus 7 is 2. Bigger number is negative, so that is a negative 2. Then bring down your numbers. Now just keep working from left to right. So minus 2, minus 3, they're both negative, so we're adding. It's going to be 5. Bigger number is negative. That's a negative 5. Bring down your 9. And now, we're back to the same thing. Signs are different, so we're subtracting. So that's going to be 4. Bigger number is positive, so our answer be positive 4. I see tons of mistakes on problems like this. One, because of dealing with double signs properly, and 2, PEMDAS has messed people up where they think they always have to add before they subtract, and they see a plus sign and they think just because there's a plus sign they're adding, which is not always the case. All right, so hopefully this helps. Like I said, I'm not going to continue order of operations. I will do that in a separate video. But there are just lots of mistakes made with negative numbers. So slow down, particularly when you're subtracting. And if you know that you make a lot of mistakes with the negative signs, use this as your friend, not as the primary tool, but try to do one of these by hand and then plug it in the calculator exactly like it's written to see if you did it correctly. So use that calculator more as a backup to reinforce whether or not you're doing it correctly, rather than just rely on it automatically to begin with. And in the long run, that'll help you out more. All right. Hope this helped. I will see you next time.